Okay, so, grab my calculator. Let's take a look at a sample problem dealing with work and energy. Let's start off with just looking at a problem in which we're dealing with just work by itself. So we've got a situation. I am going to mow my backyard. I'm going to use a lawnmower. That looks a lot more like a car, but that's okay. I was never terribly good at drawing. And I am going to push the lawnmower. Something bad happened to my neck. So, I'm going to push the lawnmower. Now, what I'm going to push it with, I'm going to push with a force equal to 50 newtons. And I'm pushing down the handle of the lawnmower. So here's the horizontal, and this handle is at a 30-degree angle with the horizontal. It's 30 degrees below the horizontal. And that's the force that I'm applying to the lawnmower. Okay? I'm going to push this total distance along my front yard of 6 meters. And I want to know what is the total work that I do. Okay, well, we're going to use one of our general equations here. And work equals our force times our displacement. Oops. So for this one, I'm going to use the equation that we're using for general physics. Force times our displacement times cosine of the angle between the two. Now sometimes some books give you something crazy where it's force parallel or something like that. I'm not even going to begin to deal with that. It's easier to keep track of it just by using the cosine approach in there, and it gives you a much better understanding of what you're doing, I feel. Well, at least it better mimics the dot product that this originally comes from. Okay, well, I know that my force is 50 newtons, my displacement is 6 meters, and cosine of my angle, well, it's likely to be 30 degrees, but let's double check. My displacement is going to be off to the right, so delta x, because that's the way I'm pushing it. My force, let me draw this a bit more clearly. Let's get a different color. Delta x is to the right, and then my force is down like this, down that handle. And we know because of the setup there that yes, indeed, this is 30 degrees. While this would be negative 30 degrees in the classic way that we've set it up, we're only looking for the angle between these two. So if we had a situation where our force was pointed up this way and our displacement was off this way, that's almost a 90-degree angle, but we'd be looking for this angle here. We wouldn't actually be looking for what the angle would be in the XY plane as we're used to before. So if I plug these in, I've got my force of 50 newtons times delta x, which is 6 meters, times cosine of 30 degrees. In this case, when I evaluate that, that comes up to 260 joules. That's the amount of work I do pushing that lawnmower across the lawn. Now, one of the things that you can do for an exercise on this, one of the ways that I could expand on this question is, I tell you that the axles on the lawnmower have a coefficient of kinetic friction. Let me erase this. Coefficient of kinetic friction of 0. Let's go with 1. So I've got some force of friction that I have to go up against. If we've got the coefficient of friction of 0.1, remember friction coefficients don't have units, they are dimensionless quantities. I could ask you, what is the work done by friction over that same period? So, we would then put in that we would need the force of friction. In this case, F sub k is what we've been using in class for kinetic friction, because we've got a situation where it's rolling or sliding. Okay, so that's my force. Then I would do delta x, my displacement, times cosine theta.